Okay, welcome everyone. Last week we kind of deferred everything to this week. We didn't have a huge number of attendees last week, but we'll move on this week and we're going to start with the agenda with the back-end discussion. I think Vipin, you were going to or had something that you prepared that you wanted to cover in this.
Yeah.
Following that, we'll talk about the EVPN new repo that's been out there and the contribution to that. So Vipin, if you want to go ahead.
Yeah, I see Ben is here. That's good. Boris is here. So we are good to go. Please let me know if you can see my.
Yeah, it's up now.
Okay. All right, awesome. I think there are not that many slides. Ben, I tried to do justice to our discussion, but feel free to, and Boris, feel free to tell me if I'm off here. So the way it exists today is that there is an NVMe remote controller object, just transport information. It has some bit of controller information, target information, some multipathing, like what type of multipathing we need to do. It doesn't really have multiple paths, but it does have the type of multipath that is needed. So a few changes that were being proposed initially in the Slack discussion was to decouple transport from the controller target information and possibly add the source transport information like the source address and port and all that. So the benefit of decoupling the transport from controller was to really enable NVMe multipathing, because that way we could specify different paths to a given backend, and then including source transport information would allow us to avoid unpredictability. If a host or source has multiple interfaces, we can be more precise on which interface to be used for initiating the NVMe connections. It can also be useful for security purposes, where you pin down exactly who can talk to who. So that's the motivation. And so what happened was, ultimately amongst some of us, we proposed like possible approaches. So Ben came up with something. I put a link to that one here, and I came up with something which is in approach number 2 here. I think in first approach, the way I see it is that we keep the NVMF remote controller object as is, which keeps the backend information, IOQs, multipathing type, digest information. But Ben was proposing we introduce NVMF path object, which is a new thing that contains the transport information, and the subsystem and host NQN as well, and reference to a controller object, which I assume is NVMF remote controller object. And then I think I'm assuming, Ben, you're open to including source port information in NVMF path object, if I'm not mistaken, correct?
Yeah, it has to have the source port information.
Okay, awesome. Okay, so then I think I came up with a slightly different approach, but keep the NVMF remote controller object, but remove the transport related fields from it. But transport information is divided into 2 parts in my proposal: NVMF port information and path information. And that's the kind of discussion we have. Port information in what I was proposing mainly contains the transport type, address family, address, and port, pretty much just these 4 things. And then path object basically combines the source and destination ports and refers to the controller object, and then also specifies maybe path priority and return interval, some of those things. So both approaches recommend decoupling path information from the controller object. Both approaches recommend optionally adding source port information. The difference really is that in approach 1 recommends keeping 1 configuration object for real path, but combine the path with the port information. In my approach, that's Ben's approach number 1. And in my approach, I'm also recommending that we create 1 object per real path. That was a concern I believe you had earlier. So we will keep one object per path. It's just that we'll use it as a combination of NVMe port objects. And I have a diagram in the next slide, which is where we can start to have discussions on to see what use case that would satisfy. But ultimately, there are two benefits that I was thinking approach 2 would give. And I had brought that up in the discussions as well. If there is a distributed backend, let's say a clustered target, which has multiple destination IPs, then it becomes, for redundancy purposes, let's say you have that kind of backend, then it becomes easier to specify the path combinations in approach 2. And also, it's as a side effect, if you have to update an object, it'd be easier to specify only what changed rather than have that multiplier effect of changing multiple objects. So that's really the use case. So you have NVMe, let's say.
So Vipin, can I ask you, in both of these cases, they end up with the same number of TCP connections, right? Like the physical connections made, the actual resources that matter are unchanged. You're talking about config objects, right? Things that only exist in the control plane, right? Configuration space.
Yeah.
And so can you illustrate very clearly why it is easier to create multiple objects instead of just specifying the 4 tuple? You know, even if you repeat yourself once or twice, you know, why?
Right. So here it is, right? So in what I'm proposing, a path object contains the source port, the target port, and some return interval and things like that. So let's say that from initiator 1, which is IP I1 and port I1, for the lack of better naming, I just came I is for the initiator IP information, and IP1 and port 1 is basically the backend, backend port, target IP and port. So a scale-out distributed storage backend could have multiple IPs that are coordinated amongst themselves for high availability and redundancy and scale out reasons. And so I'm just taking one node here in this example, node 2. So say that my initiator is having a connection to, or rather my initiator is trying to talk to the backend on these multiple ports. Then I could create NVMe initiator object once, which is representing the, or NVMF port object once, which is IP I1 and port I1.
By initiator object, do you mean the NVMF remote controller object?
No.
There is no initiator object.
No. I meant NVMF port object, which is representing the transport side of initiator.
Okay.
Right. So NVMF port object is created once, and then I can start pairing up the port objects with the NVMF destination port object. By the way, the port object in my definition is containing these 4 tuple, these things.
It has
right?
4 fields, right?
Yep.
And 2 of the fields, 2 of the fields must exactly match the other side, right? So it really has 2 pieces of information in it, an IP and a port.
Which is why I didn't consider the transport type and all that in this picture. It's the only thing you see here is IP and port. So NVMF port object contains the initiator port information, and there is a similar object created for the backend target. So now once we have created these objects, we can start to create paths depending on which paths we want to allow versus not for multipathing. And
what's the advantage of, in this situation, not just putting the IP and the port in the path object? Why do you have a separate object to represent those 2 pieces of information that you now have to look up the ID of and create separately and manage the lifetime of and all these things?
No. It's more than that, right? So let's say that, if one of the nodes need to be taken down for something, or is going down, or is, or new nodes being added and all that, clearly, I mean, it is easier for me to just create a path towards that rather than have to specify which, basically what I've really done is added a new path. So I can choose to I can choose to create the paths independent of the initiator initiator transport information, as well as from the backend transport information. So it is really allowing me to handle the failure situations and or new additions on the backend cluster or initiators coming on board relatively.
Maybe can you write it out as a sequence of calls to OPI? Because first, all the failover stuff, that's all handled automatically. Like this is not done by the control plane.
No, I didn't mean to say data path failure. I meant to say that you're taking nodes down kind of situation. Let's say you're booting up an OS, not that there's a network path gone. Let's say you want to take down a node, those kind of things. It's a configuration change in that case, right?
So can you maybe write out the sequence of OPI calls you would make to set up a path and then take a node down like you're describing? Because I don't get it.
Yeah. So let's say that you have created the initiator transport NVMF port object for the initiator and target, as and when so first thing you would do is you would go create IP1 port 1, IP2 port 2, these objects based on as and when initiators are.
Okay, so you send two OPI API calls to create port 1, create the first port and create the second port. And now you have two objects with IDs and you're managing those. They exist somewhere in your agent.
Yeah. Similarly for the port objects, NVMF port objects are created for the backend nodes as well.
Okay, so now you have 4 objects or 3. What's the scenario we're doing?
Yeah. So the scenario we could do is, let's say initiator 1 wants to talk to let's say 2 to 4 backend object, backend cluster. So let's say 3-node backend cluster, node 1, 2, and 3, and initiator 1 would like to have paths to all 3 of them.
Okay, so you're going to create one port object for NVMe initiator 1, and then 3 port objects for the nodes 1, 2, and 3.
Correct. And then I'll create 3 path, and then I'll create 3 path objects if I want the redundancy or if I want to connect to all 3 of them.
Yes, and then 3 path objects. So you've created 8 objects, right?
Correct.
No, 7. Sorry.
3 plus
7
3
objects.
7 in this case, yeah.
Yeah.
Right. And the use case I was describing is, let's say I want to go from a 3-node backend cluster to 5-node backend cluster.
Okay. So you're going to create two more
backend objects and 2 more path objects now.
So you create 4 more objects.
Correct.
Okay, so walk me through why that's better than just putting everything in the path and not having these separate port objects. Because for the case where you just have the path, you would have created 3 path objects when you had 1 initiator and 3 nodes, and then you would have created 2 more for the other 2 nodes when they came up. Done.
Well, I think you are going to have to modify all the objects, which is okay. Basically, the thing is, do you want to club in all the information in one and only modify part of it, or do you
it's literally two pieces of information. It's an IP and a port. It's like no harder than just plugging in, looking up the ID of the thing that represents the IP and a port and putting that in.
Sure.
Vipin, is there any properties for the port objects? So I see where you're coming from, right? So typically when we design a model, so we'll try to keep it separate so that when we have large amount of properties coming for port and large amount of properties coming specifically for path.
Right now, I'm thinking only IP, and right now I was thinking only the transport properties, which includes the address family and port and address. I don't know of anything more right now.
Okay.
Yeah.
And then when you go to
we can conjure things, but I really don't see anything significant really coming along.
Yeah, and when you go to delete the initiator later on, right? You want to disconnect. How do you manage the lifetimes of all these objects you created? When do they go away?
That's actually the better part of it, Ben, is because you can the main thing that you get out of this is the life cycle of these objects could be triggered directly based on when those entities start to come and go. For example, if my initiator one has gone away, in that case, I could delete the initiator and the paths, but I can keep the backend port objects which are used by other initiators.
But if you're just creating a path for every path and you don't have these separate port things, then you don't even, like, that's not even a problem, right? Like when you delete the initiator, you delete the 3 paths that are associated with it. But there's other initiators that may have paths to those same nodes.
Yeah.
Right, like from their own IPs, and those still exist. They're independent. Of course, they don't
Yeah,
get
they are
deleted.
independent. Correct.
It's no better. It's actually just worse. You just have a lot more objects to manage.
Well, objects are tied to what they represent, and their life cycle is tied to what they are connected to. I mean, in that sense, you can just create maybe one giant NVMe path object with all initiators and all targets, and keep on updating one object. Absolutely, yes.
No. I'm saying you create one NVMe path for a unique 4-tuple, right? Well, it's really a 6-tuple, right? So there's the source IP and port, the destination IP and port, and the host NQN and target substance NQN, right? So you have 6 pieces of information. That creates a TCP connection and admin queue. That's the actual unique resource that we need to minimize. And we have one object for those. And those are always directly associated with a controller. If an NVMF remote controller, the backend thing, the initiator in your picture. And if the initiator goes away, it just deletes that path. Those paths are never shared. They don't hold that much information. Right. And this also means like the agents don't need these lookup tables, to hold these objects and track these objects so that you can look them up by ID. You never need to.
Sure. I'm not denying that. I'm not denying that won't work. It could work, definitely, yes. But anyway, this is a perspective. My perspective was that if my IP or a port is changing on node 2, why do I have to go update so many other objects? But that's okay. I think we could update all objects corresponding to it. Let's say if I have 10 initiators that are pointing to path to node 2 on the back end, then I have 10 paths because I have 10 initiator, each one, let's say, using the same path to this one. Here, I don't have to go update all these paths. I can just update the port object and be done with it.
I agree with that. That's that you can make one RPC call to update just the port for the node if you are moving it, and it's supposed to move all of the connections around, right? But I actually think that is dangerous because it makes it seem like a really simple and cheap operation. But what that operation is doing is disconnecting 10 paths and reconnecting, creating a new 10 paths. And I'd rather see that be very explicit, like what's really going to happen to the connections that this DPU or IPU is making as 10 separate calls, right? Like I prefer not to hide the complexity of what's happening there.
Yeah, I mean, just a short while ago, you were arguing that we have to make 10 calls. Now here you're saying making 10 calls is better.
But it's 10 calls for no value, for no communicative value to the user, right? If the 10 calls do something, like they did something to the data plane, then it's useful to make that very explicit. 10 calls to just create config objects that don't mean anything or do anything to the data plane, I don't want. But if you're going to make calls that are actively changing the data plane, there's IO running, it's going to change these things, then I would prefer that to be really obvious.
Okay, sorry, Boris, why don't you go ahead? I think you should hear others out as well.
No, I just wanted to add a little bit of color and ask both of you, Vipin and Ben, what happens in this diagram when we are talking about locally attached drives to the DPUs in addition to the remote drives, which we are discussing so far with IP the ports? Are we creating a new type of NVMe path, which is local on PCI Express bus, for example? Just interested to hear how that would play in this deployment.
Yeah, we would just, the port and the IP are just strings, right? So we would put the BDF in there. There's no source information for PCIe, right?
Yeah.
So you just kind of
Yeah.
ignore it.
Yeah, that's why source is optional. I agree. And then there is address family and address, type associated. So you can do transport which is not TCP IP, for example, in this object. Right. So we have transport type, address family, and this one. So we will probably need to specify the PCI addressing here, and source is optional.
Thanks.
Yeah, I'm not hung up. Honestly, I'm not hung up. I'm just describing the differences in the perspective. I felt that creating an object for what is conceptually represented is where we want to cut the gRPC layer, not the data path. Whereas when you firmly believe that we have to reflect the data path more accurately, whereas I'm thinking that gRPC layer is representing the configuration object as seen by the user, and if user is modifying one concept at configuration level, then they should be updating and changing that object, and not more than that. And that's where maybe the difference is. Either way, I think we can.
Well, it's, I mean, the OPI objects are definitely config objects, right? But they should communicate as much as we can about what's happening to the data plane when we change them, right? And that's how we inform the users what's really going to happen, so they have a mental model, right, of what's going on in these devices. And so I want to try to make the config stuff have an obvious mental map to what happens in the hardware, right, as much as we can.
So so this is for NVMe over Fabric connectivity across an IP network, correct? I
Right.
missed. Okay. And we know there's a few ways that are standardized to do that already, right? So there's the 8010 central discovery controller zoning model. And then there's sort of the direct, so with the central discovery controller, and then there's the direct discovery controller, where you wouldn't directly configure the connection properties of the connection in the first place, right? You would use the NVMe.org defined protocols. So this is to cover when somebody would want to build a direct NVMe over Fabric connection
Exactly.
model. And we
we have not dealt with NVMe discovery in this work group at all. It's quite difficult, but discovering the paths in reality is going to be done through a discovery controller, in almost all cases.
But so this set of configurations then is to cover, again, you have some other method of discovering what you should connect to, and you don't want to use the DDC or the CDC to do the connection setup, because that's well-defined.
Correct.
Works. This is where you did some discovery, and now you want to go and directly effectively manually configure API.
Yeah, your orchestration system is manually setting up direct one-to-one mappings between initiators and targets.
Again, without using an intermediary of the zoning model, which covers all of these cases in spades, including timeouts and everything else.
So I agree with you that overwhelmingly, going forward, the way this is really going to work is you'll define one path from your IPU or DPU, or some number of paths that connect to discovery controllers rather than the actual place, and then they'll tell you the paths, and then they'll update the paths as needed and move things around. So you end up not configuring these paths very often in reality. But I think a lot of deployments like today or last year didn't have all this discovery controller stuff, and they're manually setting up point-to-point connections effectively through their orchestration systems.
Okay, yeah, and as you say, you can use the this method for configuring the connection to the discovery controller itself. And it would be the same APIs to do that as it would to set up all the individual connections. So then you have some flexibility, and we need the connection to the discovery controller in the first place. And
well, and it's complicated too, because you actually need to support multiple discovery controllers, right? In case one goes down, right?
Oh,
And you have to be able to fail over. And so SPDK supports all that today, you know, in our config APIs.
right.
But basically, in the future, I think going forward, people won't be setting up these paths for point to point. They'll be setting up, multiple connections to a discovery service, which will then be telling them all their paths, right? Like that's really how it's going to work.
I know I know the insides and outs of the CDC and DDC operation. So the point I guess I'm making is that I think I'm coming down on your side, Ben, a little bit of, not that we're fighting or picking sides, but I'm thinking that being more explicit rather than implicit may actually be better, Vipin, in this case, because again, what we're managing here is, in reality, or let's say 5 years from now, what we'd ideally be managing on the DPU is all of the discovery controllers that DPU has to map to, all of the universes of distributed or disaggregated storage that DPU needs to virtualize and represent into the server. So having a sort of a more explicit config of those discovery controller connections might actually be a good thing rather than a bad thing. I don't know, maybe I'm off, but just as I was listening, that's what was occurring to me.
I think the essence of the difference between what Vipin suggests and Ben suggests, from my perspective, at least, is when you want to make a change, even if you're using discovery controllers or not using discovery controllers, if you want to make a change because your target node failed over to another, then you make a single gRPC call to say this node is down and this is your new IPN port. And that's it. And what Ben is saying is this is dangerous, which I understand the sentiment for sure. In Ben proposal, you need to update every single pass that is connected to node 2 that is now failed over to node 3. So the amount of gRPC changes are bigger, but I understand Ben's argument why this is not reflecting the actual admin queue connectivity and doesn't really represent
well, and then reality. Joe's argument extends that to say what these paths are really going to be are not the actual data plane paths. These are paths to the discovery controller. And so the discovery controller will fail over and move around data plane paths automatically. You don't have to do that through OPI, right? Like that,
right.
It's failover between paths and discovering new paths that have become available and stuff. That's all automated through NVMe or Fabrics. We're just setting up the initial set of connections, right? And if you're setting up the initial set of connections to a discovery controller, unless you're like changing your discovery controllers, or you're taking a discovery controller down and adding a new one, you don't need to change anything on a failure, right? Like that's done in a different way. It's not done through this OPI API anyway.
I agree, but when we do talk about discovery controllers, and if discovery controller change its IP and port, then it still goes to the same problem of discovery change.
Well, but you need to change all the paths.
Yeah, sorry. Go ahead.
You just have a lot fewer of them, right?
Absolutely. Yes.
So that it's not so bad if you're going to make like 6 calls. Like if we were going to have to change 5,000 paths, like I think probably we should have at least the node side port thing, right? But I don't think we are, right? That's not how it's going to work.
If you have 1,000 of initiators, right, it means you have what, 1,000 paths. No?
But even if you like fail over a discovery controller, you can actually do that through the discovery controller. The discovery controllers can point to other paths, of other discovery controllers. push out the update, have everybody fail over, and then kill the old one, right? It's like you don't ever actually need to do this through
Yeah, and
OPI.
yeah, in a central discovery controller model, which is where all of the distributed storage backend storage networking should end up if they're smart, is everything is in one place, right? The entire universe of that storage network's configuration is in one database effectively, and everything is automated for changes if you just change the groupings in that database. In other words, you change the zoning and all of the individual connections automatically follow. That's the sort of the central point of having a CDC at all, right? Is that notifications go out,
Yeah.
are torn down and set up again, and the only thing you have to sort of configure by hand is that connection to the discovery controller. Now that can be automated as well, but there are restrictions there on some of the network details, and not everyone's going to want to allow that. So we have to have an API to configure that. The notion of managing all individual connections in a scaled environment is a little frightening, although in point of fact, you could write an equivalent of the central discovery controller directly yourself, right? I mean, it's not rocket science. You could go write the equivalent of that yourself and manage all the connections directly through APIs. And the API ought to, in theory, let you do that, although I don't think it's a good idea for anyone to implement that and sell it.
Yeah. The other thing too, remember each of these initiators in these boxes we're looking at, these are different physical devices. So,
Yeah.
you know, when you move a node, you only have to, for every physical device, you only have to change the paths that initiator is connected to, you know, and that number can't be that large because these things just can't maintain that many connections, right? Like it can be 1,000 or something, right? But it's any individual DPU like just cannot be connected to that many nodes in general, right? And if you move one node, that actually means you're going to have to make one call on every physical IPU or DPU in both situations, right? Because the config objects exist in the agent down running on the, you know, on the IPU or DPU. And so if you move node 2 to a different spot, then you have to make a call to move node 2 on the agent running on initiator 1. Then you have to move node 2 on the agent running on initiator 2. Then you have to move node 2 on the agent running on initiator M. It's actually the same number of calls, right? Because that initiator has probably only got one connection to that node. So it actually doesn't help to switch these things unless, you know, for some reason you have multiple connections to the same backend node from one initiator.
Fair enough. So let's go with your approach, Ben. Like I said, you know, I'm not going to. It's going to be translated quite easily one way or the other, and especially if it is more aligned with the discovery, we can go with what you're proposing. The fundamental still remains true that I think we are getting the goal of the commonality, which is like decoupling the path information from this one and including the source port information. Those two are definitely a huge benefit. So given that, I am assuming you're going to submit a PR, which I could comment on for this change.
Yeah, and actually I have one open that I wasn't sure what to do with, that I'd like to run by the group before we close this.
Okay.
I didn't know in the path object, right now I have the host and the subsystem NQN. And
yeah,
I'm
you
not
had
sure
it.
that's,
In fact, I was curious why, but yeah.
I'm not sure that's the right place. Maybe I should
Yeah.
move that to the NVMF remote controller.
Right.
Yeah, that's what I wanted to suggest to you, Ben, as well. The NTN should belong to controller, and the path should be only a
The
transport.
4 tuple.
Yeah, like you have
Okay,
in
I will do
SPDK,
that.
the transport ID kind of thing.
Yeah.
That,
All right,
that's
I'm
kind of
gonna make that change, and then also, you know, it'll be the full 4 tuple with the source too.
Yeah.
Because
Yeah,
I
if you can.
completely agree on that point. And then we'll go from there.
And I encourage you, Ben, when you do that, just put somewhere, maybe in the comments or something like that, we do want to support local PCI Express devices. So just, we need to make sure that is captured in the...
I guess I have to have a type and path or something.
Yeah, or in the comments, how would one use that or
Yeah.
this object if you are PCI Express or versus the TCP?
Yeah.
Thank
Okay, I will clean that up and get it going.
Thanks.
Yeah, thanks, Ben.
Okay, great. We'll look forward
thank
to
you.
seeing, we'll look forward to seeing the PR when it comes out, and we'll get it reviewed and get it put in. Great. Okay, the other topic for this week is we've got a new repo for the EVPN gateway. Boris, did you want to walk through what you've put out there so far?
Sure. I see Dmitrios here on the call as well. What I wanted to just raise awareness that this is happening. So if people are interested into contributing, we are very welcoming all the contribution in the space. So I created a new repo, OPI VPN Bridge, it's called. As usual, all the regular infrastructure for OPI, including pod coverage, CI/CD pipelines, Docker Compose, pull request, push into Docker Hub, everything is implemented in Go language. We put several diagrams. How would one configure that? So we're looking into gRPC client, as usual, using OPI APIs that currently in the pull request review cycle proposed by Intel and Ericsson. Going into our new OPI EVPN bridge, and this will configure both the gateway FRR and both Linux bridging, maybe more stuff here. This is a POC diagram that we currently support with L2 and L3 EVPN, so the networking people can look at it with VXLANs. All the code is just starting to emerge, so we don't have much yet because the API proposal itself is not merged yet. So basically, we have just a simple example here how you create new bridges and new links and everything like that. But what's interesting is we completed here the entire CI/CD pipeline. So we basically spin up several FRRs for spines and leaves. We configure all the different network interfaces with bridges, VXLANs, and then we just run traffic. We're pinging through all this traffic, so just to verify that everything is up and running. So you see all the different networks and everything. So just don't intend to deep dive on this. We have one pull request to actually enable L3 already, and it passes the testing on local machine. This is adding VRFs into this picture. And we have some problems on the Azure instances with CI/CD pipeline. Azure instances don't support VRFs in Linux kernel. So we just reading and trying to understand what's going on here. But what I wanted to do is, first of all, to publish this, see if people want to contribute into that. And once the pull request is approved, we want to continue working on this as well. Any questions from anybody?
Boris, in this POC and in this whole CI that you explained, the configuration is happening within the DPU or mostly on the host level here, all that VRF configuration and all that. In other words, is DPU only configured through the OPI APIs, or there is more going on the DPU here?
Everything is running inside the DPU, and everything is configured on the DPU through the OPI.
Okay, so the VRF, configuration, or rather the module that you're suggesting gets loaded That is also happening on DPU, or it's happening on host?
I'm not sure yet.
That
Go ahead.
Maybe I can help with that.
Sure.
I mean, every DPU, IPU component, it have an ARM core complex, right?
Right.
And where you run Linux, and this VPN gateway bridge, which will be initially of 3 components, like the gRPC server that will actually get the gRPC requests, and then it will have the FRR Linux component in there. And also a database where it will hold all the objects that you create. This as a whole is called the VPN Gateway Bridge, and it will run also on the ARM cores and on that Linux system on the XPU card, and it will be responsible for taking the calls and configuring the FRR control plane, which is your BGP stack, actually, and also the Linux bridging and routing, which is your slow path. And from there, each vendor should create a plugin that will actually
Accelerate that.
yeah, accelerate that by monitoring whatever happens in the slow path and translate that to the fast path.
And I can share this picture that Intel and Ericsson shared with us publicly in OPI that hopefully can make more sense. So we can see here all the components, the EVPN gateway, FRR, we see the Linux bridging and routing for slow paths. We see also the IPsec as well here, and the IPU infra manager that Intel and Ericsson creating together. This is what we're trying to break into the pieces, and one piece that is responsible for EVPN gateway, FRR, and the Linux bridging here is the OPI EVPN bridge that we're currently creating together in open source way. Yeah. And the vendor plugins in blue, this is what Dimitrios was talking about.
I have more explanation of that in my pull request. In the API pull request, I have added some markdown documentation around this picture and some explanation. So if anybody is interested, can actually go to that pending PR right now and read it out.
So the existing POC right now is running in a Linux host environment, but will eventually move on to the DPU. Is that what I understood from that?
That's correct. Okay. Right now, like initially until Q4 2022, we had like the AVM on the host where we was playing the role of the SC cores, but right now we are making steps to actually have every control plane run on the SC cores down on the XPU.
Sure, that makes sense. I was just trying to align it with the issue with the VRFs and running in the Azure cloud. So that just makes sense. Okay, thanks. Any other questions?
The FRR configuration is done directly and not through OPI at this point?
Today, since we didn't merge any API proposals, so all of that currently is static configuration, either in config files for FRR or for VRFs and bridges. It's in Docker Compose static configuration with IP and okay. Netlink. Once we have either choosing within your cloud APIs, which are very similar constructs, or we doing the Dimitrios proposal for the L2 and L3 protobufs. Once that is done, it's on going away from the static configuration into the protobuf gRPC calls that will translate into the actual configuration on the fly.
Makes sense. Thanks.
So I wanted to use this time once to show you this work is happening, but second of all is I want to encourage contribution, because currently it's just a little bit of Dell side and a little bit of Dimitrios that helping out with this repo. So if anybody on the networking side interested in participate in this, we are very welcoming. We need basically to translate gRPC APIs until we merge the Dmitri's proposal, I'm using VPN APIs for cloud so far. So we need somebody to help us writing the code, translating the VPN gRPC APIs for networking into the actual Linux command for netlink, configuring the bridges and everything. So I'm using already today the Go language libraries that can help with that. And same, we need to configure with FRRs. FRR support protobuf as well for the northbound APIs, or VTYSH as well, over Telnet, for example. So we need working hands to make this contribution happen.
Boris, I would like to contribute, but at the same time, do I need Intel DPU to contribute to this?
No, it's all running in the Azure. Docker Compose, you can run it on your host, you can clone the repository, Docker Compose app, and that's it. Everything is up and running.
Okay. Okay, let me touch base with you offline then.
Yeah, for sure. I encourage people to clone this repository, do the Docker Compose app, see everything is up and running, see the ping is working across all of that configuration, and then we can make a contribution. You don't have to have any DPUs in your lab to make this happen.
Makes sense. Thanks.
Thanks, Mark. Thanks, Vipin.
Okay, great. Well, that's pretty much all the topics for this week. We'll give everybody back about 10 minutes on their calendar. And we'll figure out what the topics are for next week. Hopefully we'll either circle back on some more of our Kubernetes discussions, or we'll move on to some of the other things that we need to work on. So thanks everybody for attending. Thanks Vipin, thanks Boris for going through those two topics.
Yeah, thank you, Ben. Thank you, Boris.
Thank you.